level the scheduling algorithm later. Okay? So this is the next one is this is a process by process. So instead, what about we are going to anyway, we have the many processes. I try to be fair. So I divide the advising hour by 5 minutes. Always 5, 5, 5, 5, 5. If there is a student one, assign. Then if not complete, going back to end of the queue. And the next student. And the one will be, if there is no one, then the one will be selected. 1, 2, 3 until terminated. So at the time, this is called the time unit. In operating system is called the time quantum. So time quantum is the fixed size of the CPU time. That time is all CPU time will be divided by the time quantum that assigned for the process in the ready queue turn around. It's called the round robin. So round robin approach. So how can you implement? So you can divide the job. So first, this is current status of the ready queue. So we have the 4 process in the ready queue. Okay. Then the P1 is the first one, so P1 will be selected. This time quantum is 20. So it's divided by the 20. Each process will get the 20 CPU time for each round. So P1 will be selected. Then after 20, P2. At this time, the P1 remaining time is what? 33. Okay? Where do you manage such information? Always? PCB. PCB you can keep, record such information. Then you don't have to write down the way. So only PCB. So that's simple to implement. Then P2 will take the. What about the 17? Okay? There are 2 types. One type is, even though there is a remaining time like 3, we don't care. Just 20, 20. 3 milliseconds, nothing. Because instead of selecting whatever, just 20. Okay? That's one approach, but most of the case to maximize the utilization, the start, the P2 go to the terminate and select the next process from the queue. That is a P3 and so on. That is the reason it's not exactly by 20, sometimes less than 20. Okay? So this is the round robin approach and quantum trend. It's very interesting. What if I increase the unit size, quantum size to the 1000? Does it work? Yes, it works. Then you realize, for example, if 1000, P1 will be selected and terminate. Then P2, P3, P4. It's a arrival time. So order by the arrival time. It will be same as first come, first serve. So when we are using the round robin, if we increase the quantum time, it will be the first come, first serve. Because of that, we don't have to implement separately first come, first serve. Instead, we can just implement the round robin, then increase the amount of the quantum size. Then it will be automatically first come, first serve. Okay. So that is this slide. Okay. So the benefit of such a round robin is fair first, because at least give the one chance of the round. Okay. Problem: if we have small size of quantum, overhead of what? Context switch. A lot of context switch will be happening. Even though we do not consider in this the practice, but in real the system is the overhead. Okay. That means it's not easy to determine the optimal size of the quantum unit size. It depends on the characteristic of the process. So to address, we are going to consider the multi-level. We will see that soon. Okay, so multi-level queue means how many queue in the ready queue? only one queue. So we are selecting the next process from the one single queue. Instead of one queue, we are going to manage several queue. That is called a multi-level queue. Not multi-queue, it's a multi-level. Level means level 0, level 1, level 2. So each level has the meaning. So we will see to understand such a multi-level queue. There are different types of process in the operating system. The mostly system process, operating system process versus application. Nowadays, it's not easy to clearly divide this is a system process, this is the application process, but roughly we can say the system process. Sometimes it's called the service program. So if you go to the Windows, the task manager, there's a list of the service process running. Many of them you don't use, but it's running. It's selected by the operating. You can change it, but unless you are really expertise on that specific operating system, it's very hard to. So mostly just leave it, and it's a still processor. It consumes, it wastes the computer resource. So that is the system process. Also in Unix system, mostly they are daemon process, service process. It's running forever like the SSHD daemon. Means so there's a server side program. So using SSH client, you request, I'd like to connect to the system. Then the response and so on. So that is a service program that is sometimes called the service program will be discussed later. Okay, anyway, so that is a service program. Then another types of the process is you have practiced the FG command and BG command. Okay, foreground process, background process. So you can run the process as a background, and also you can bring to the foreground. Foreground is you can see what's going on. It's interactive. On the other hand, the background, it means, so it's running and forget about usually. It's sometimes called a batch job. So in this case, the foreground usually need a fast response time. On the other hand, the background need what? Fast response. Instead, fast minimize the turnaround time. The batch job usually need the total amount of time should be reduced. Okay? So to consider such a different character like the system and the application process, or foreground process and background process, or interactive process, or the batch process, we cannot use only one, the CPU scheduling algorithm. Instead, we will use later, for example, foreground round robin. Why? Round robin provide fast response time. And on the other hand, the first come first serve is so throughput is good, and also the turnaround time is good, even though waiting time is longer. Okay, so we can accumulate such a different requirement by considering multiple. So to use the multiple scheduling algorithm, we need to consider the multi-level queue like this one. So we have the highest level queue, next level queue, next level queue, next level queue, next level queue. Okay? Then select the process from here, 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 here. Okay? Question. So if you have only one CPU in this case, it's a good idea to consider the different level of the queue for each such a process by considering the characteristic. How can you implement? Anyway, if you have only one CPU, at certain time, only one process is running, right? Which means, first you need to schedule which level will be selected, okay? Like for example, system process 50%, and this one 10, 10, 10, 10, like that. You need to schedule level by level, queue by queue, okay? Schedule. Then select If this one is active, then select the process from this level of the queue. So it's a two-level selection. You need to schedule level by level, then run the different algorithm. This one is the first come first serve. This one use round robin, and so on. Okay, so that is a multi-level queue. So this is one of the examples of the multi-level feedback queue. Multi-level feedback queue is slightly different from the multi-level queue. Multi-level queue, first we select which level will be selected. Then for that selected level, we apply the scheduling algorithm, like the round robin or the first come first serve, and so on. Multi-level feedback queue means one of the problem of such a multi-level queue is it's not easy to define this process is the system process. This is the application process. This is the batch job. It's not clear. Okay? It depends on sometimes in the middle of the processing and so on. To address such a problem, we are going to use the multi-level, but output of this one will be input of the next level. Idea is, why don't you take a look at how many levels we have? How many queue? 3 queue. Always the process will the entry, the first level here, small quantum size, which means round robin, small quantum size, provide fast response time. It will be selected right away. Okay? Then give the chance only 8 times second, small amount of time. So like that, for example, I have assistant. I'm the advisor and I have assistant and assistant. Then the student come in the advising room, my officer. Then first see the GA. First GA. First GA will take care the simple job like the submission or pickup. Okay, but if you solve that all the problem, then it's terminated. You go back to home. But if you need more time, and next the GA will take care. Next GA will be the longer, like the 10 minutes. Still, if you do not solve it, I have a question, but he didn't answer, then finally professor will take until you solve the problem. So it's longer and longer and longer of the quantum size. If the process is enter here, there is done, terminate. Otherwise, next level. And next level, finally, first come first serve will be terminated. Idea is, even though we do not classify the characteristic of the process, we do not know the CPU burst time. But while we are processing, if needed, going to the next level, which need more time. Okay? Bigger quantum size. So this is called multi-level feedback queue, using round robin and first come first serve. Mostly, first level is round robin with the quantum size. The last one, usually first come first serve. Question. When I ask you to implement this multi-level feedback queue with the same condition, how many schedulers did you need to implement? How many scheduling algorithms? 4? 1, 2, 3, and scheduling of the 11. Any other? Probably 2 will be enough. First, round robin. Round robin, then you can apply the round robin to here with 8 argument or option. Okay? Same round robin with 16. Last one, round robin with huge number. Then automatically first come first. All are same scheduling algorithm. So you don't have to implement separately. Just use the same. Then another algorithm, scheduling algorithm. Since we have the one CPU, we need to schedule along this. Even you can use a round robin for this level. Okay, sometimes. But the round robin is the same amount of time, so you need to give the different the time So to do that, you can use the different algorithm for the along the level. So that is a multi-level feedback tube. It's a benefit. It's a very flexible. Okay. So automatically we don't have to define the characteristic of the process. You don't have to worry about the CPU burst time. It will be managed by the different level. Problem? Is it really complicated? Compared to other algorithms, it's a little bit complex. However, it's not really complex to understand. The problem is how often the scheduling algorithm is running. As we have seen here, it's a short-term scheduler. It's a millisecond level, even though sometimes less than millisecond, the algorithm should run. So how many times per second? It's almost millions times it's running. So if your scheduling algorithm is a little bit complicated, little bit more complicated, it's a huge impact. So as simple as possible. So when you apply this one to the real system, it will be the overhead of the entire system. So because of that, many of the operating system use a very simple. Try to use the simple scheduling algorithm. Most popular one is round robin. Round robin with a different quantum size. Round robin is used a lot. Or priority, explicitly assign the priority value. Okay, in case we need. Okay, so that is what time is it? Oh, it's already 52. Okay, so as I imagined, it's not. So on Monday, bring your laptop. We will have the last exercise left. Okay. Then we do not have the midterm exam the next week. Instead, the October 23rd. So I'm going to assign the test, the midterm exam, to check your system requirement. You need to install the lockdown browser before you come to the classroom. So if you never use the lockdown browser, please solve the testing problem. To do that, you need to install. Okay? Any question? Okay, so see you next week, and have a great weekend. I moved the midterm exam to the October 23rd.